Yes, I like that. That's a mouthful. Reflection, if you want like a simple definition, reflection is light that bounces off of a surface. There's a rule to this and all that. We'll get to that a little bit later. But it's light that bounces off of a surface. And there's a rule about this. It's called the law of reflection, which we'll get to momentarily. Okay? Good. Carson, what about refraction? What's that one?
I'm not sure if it's right, but I have the angle of incident light will be the same as.
So that's the law of reflection. So we'll come back to that. Ethan, what you got for refraction?
When light bends and passing through one medium to another.
Good. Light bends when passing from one medium to another. Good. All right. Levi, what about focal point?
I said it was like the point of focus, or like where all the light converge.
Yes. Point of a mirror or lens where light converges. Good. All right, Solus, what about a real image?
So I got a real image is an image by light rays that convert the location of the image and a real image.
Okay, so real image is light converges at an actual point in space. Light goes to an actual, real, logical place. Okay, there's an actual place where light goes. Okay, Vaughn, what about a virtual image? Yeah, so a virtual is when light converges at an imaginary place in space. I'm going to show you both of these. Okay, so you're probably saying to yourself, Mr. B, I have no clue what any of that means. Okay, let me show you. This is a real image, and I will pass this around so you can see it. Now, you're saying to yourself, Mr. B, that's not a real image. That's an actual thing. That's a penny. Yeah. Okay. Here is the image. That is the exact same penny, but it's an image of it. And you're looking, you're saying, no, Mr. B, that's the actual penny. You didn't do anything different. It's just the penny looks different. Except, whoop, there's the penny. This is an image. It's a real image. There's an actual place where I can touch. There's a real place in space where that light intersects. I can't actually touch this penny because it's just light. Okay? There's nothing to touch there or move because it's just light converging in that spot. Also notice something interesting. See how the penny's upside down? It's a little hard to see with the reflection off the light, but you can see the penny's upside down. Notice that the actual penny is right side up. So something I want you to add for real images is that real images are always upside down. Real images are upside down. Oh, there. So you can actually see it. So what's a virtual image look like? Like that. Okay, there's my face. You can see my face in the mirror there. Okay? So you might be saying to yourself, well, Mr. B, that's just a regular mirror. It doesn't look like anything funky. Your face is small, but other than that, it's just a mirror. This is a virtual image, and the reason it's a virtual image is because I can't touch that image. There is not a real place in space where that image forms. It forms inside the mirror in an imaginary place, in a fake place. It doesn't exist in a real place. And notice that it's right side up, so virtual images are right side up. Now you're saying to yourself, Mr. B, I don't understand this. This is weird. What do you mean this real place in space? Well, what happens to light that goes through a lens? Light that goes through a lens passes through the lens and comes out the other side. Here is a real place in space where that light intersects. What happens to light in a mirror? It hits and bounces off. That is a real place in space where that light intersects. So these are real images. Where does the light intersect? Has to intersect somewhere. It intersects this way. It intersects on the wrong side of the lens. Here's the other one, the mirror. It intersects on the wrong side of the mirror. These are virtual images. When you look at yourself in the mirror, you don't actually know what you look like. Because, one, your image is virtual, so it's not projecting an actual, like an image in actual space. But more than that, when you look at your virtual image, they're flipped. Okay, virtual images are flipped horizontally. So when you look at yourself in the mirror, you're seeing a backwards version of yourself. So you've never actually seen what you look like. Because even if you're looking at a camera or a photograph, you're still looking, or a phone, you're still looking at an image. You're not looking at the actual thing. So you don't know what you look like. So, congratulations.
That's fine. But the other person can see you.
Yeah, everyone else knows what you look like, but you don't know what you look like. Yeah. Yeah. But you never actually seen a true image of yourself. Okay? All right. Let's break here.